Okay, so we're going to figure out how we're placing these values of radians on the unit circle. And the big thing that hopefully we're realizing is that all the way around, what we're doing is we're finding a central angle that we're rotating around the circle that we've been in degrees most of your life, but there is another unit measure called radians, and it's based on the radius of the circle, which then we can relate to any circle. So the full distance around is 2 pi radians, because 1 radian is the distance that the radius would wrap around the arc. So this is about 1 radian that we notice, well, then it relates to the circumference. If the radius is 1, then it's 2 pi. So really radian measures when we start to find where they are in the circle is just divvying up this circle. We're dividing into certain pieces. So for example, if I divide this 2 pi in half, this blue angle right here, blue angle right there is pi radians. So pi radians is 180 degrees. Pretty straightforward from that. What we do is start breaking that up even more. So for example, if I start at 0 here, and then I take that pi and I divide it in half, that would be this 90-degree angle here, which would then be pi over 2. And just how we say it is usually the number of pi's over a certain fraction. So I have this 1 pi over 2 and 2 pi over 2, and I just start counting how many quarters of the circle I have. 1, 2, and then this would be 3 pi over 2. Just like if I was talking in degrees, it would be 90. I'd have 3 90s to get to 270. I have 3 pi over 2s to get to this spot. And then eventually we have 4 pi over 2, which simplifies to 2 pi. So really what you could do is mark all these up in a certain value and then just reduce all the fractions. But we want you to know what each piece is as well. So there's some other ones that are nice that we talk about as well. And again, just splitting up this circle in certain pieces. That if I split this top half, and usually for me, I look at the top half as just pi, and I'm splitting it up into certain, a number of pieces. So if I split this little section in half and this little section in half, I've created 4 individual pieces. So here's 1, 2, 3, 4 pieces. So I don't have to scribble, I was going to color them, but I have 1, 2, 3, and 4 pieces. So that means this angle, that central angle there, even though we read it on the outside, it's telling me how big it is. I'm taking pi and I'm dividing it into 4 equal pieces. Okay, so if I know what one of those little quarters is, I have 1 pi over 4. That gets me to 2 pi over 4, and this will get me to 3 pi over 4. And then I just keep counting my ways around. Now I could have split up the whole, I guess I could have gone out, a line all the way across. And I could have thought of this, well, if the full thing is 2 pi, now I've divided it into, oops. If I have 2 pi, I'm dividing it into 8 equal pieces. Sometimes that works for people better. Like I said, I split up the top half of pi, but you could split up the whole thing of 2 pi. But 2 pi over 4, or 2 pi over 8 is the same as pi over 4. So you're getting the same answer. It's just how you get there. No big deal. So I have this 3 pi over 4. This becomes 4 pi over 4. And I just start counting. 5 pi over 4. 6 pi over 4, which reduces. Then I get 7 pi over 4. And then back to 8 pi over 4, which is 2 pi. Now we can keep going. We don't have to stop here. It is a circle we can keep rotating, where this is in the same spot as 9 pi over 4. I'm not going to say that these are equal to each other because one of those angles is just this little guy, and then 9 pi over 4 is all the way around to here. So we got to be careful that these aren't equal, but they are in the same location. They're in the same spot on the circle. So the other two go a little more hand in hand. It's our pi over 3s and pi over 6s. So this time I put the vertical axis, the y-axis, kind of shaded like it's there, but sometimes it's kind of hard to see how we're splitting this up. So if I take, I'll make these ones blue, take this top half of the circle, and again it's still pi, and I split it up into thirds as best I can here. Kind of close enough. My middle spot is probably a little too small. but I'm trying to cut it up into 3 equal pieces. So if I'm cutting that into 3 equal pieces, like we did before, that would be a pi over 3. We could also think of it like this if we, again, cut all the way across. That's why I took or made that that line gray there. It's just we don't want to think that from here to here is a third of it. We actually have these 2 pieces to make that a third. But then I'm cutting up the 2 pi into 6 equal pieces. So it's a little tricky, but pi over 3 relates to 60 degrees. And we'll talk about pi over 6, but even though it's got a 3 doesn't mean it's 30 degrees. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and then 5 pi over 3. So that's our pi over 3s individually. You know what, I'm going to go back on my slides. I think I'm going to put the pi over 6s on here as well. We'll make those, make those lime green. So pi over 6 is taking that half of pi over 3. So I'm going to draw it so it kind of overlaps here. So that's 1, 2, 3 pieces. 4, 5, 6 pieces. And then I have, I got off my line feature here. We have 7, 8, 9, 10, 11, 12 equal pieces. So again, that would be like 2 pi into 12 equal pieces, or I took that pi and split it up into 6 equal pieces. Now, a lot of these are going to overlap with the pi over 3s and the pi over 2s that we had already, but that's okay. So we have a pi over 6 for that first angle here, 30 degrees. Then I have 2 pi over 6, which is pi over 3. Now this is 3 pi over 6, but 3 pi over 6 is the same as pi over 2. So then I have 4 pi over 6, which reduces, but we got a new one, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. And that's hard to do, to say numbers and write different ones, but 9 pi over 6, 10 pi over 6, 11 pi over 6, and then I'm back to 2 pi. Now there's a reason we picked these ones. Could I find where 7 pi over 12 is? Yeah. I divvy it up into 12 equal pieces. It's not the nicest, you know, 15 degrees is a pi over 12 and kind of count those. Yeah, we can find other radian measures and where they're located on the circle. But here's a picture of what we need to get kind of locked in and locked down. There's actually a mistake on this one too, so ignore that. That's 7 pi over 6. Thought that was kind of funny, but just grabbed it quickly. So we have all of our, 30s, 45s, 60s all together on this one picture and have all these radian measures. So something I would challenge yourself to do is have a blank one of these and be able to put all the radian measures, all the coordinates, all the degrees in under 5 minutes. That's kind of the goal that, when we have those games that keep playing and finding where they are, because this is what we'll add on to that essentially in the next day or so or coming up. Is problems like this that you've maybe been seeing in the homework already, that we might say, hey, what's the sign of 3 pi over 4? So a little review from the days before if we're doing all right. This is something I have my students repeat in class. We say it's so much. What is sine asking for? Sine is asking for the y direction or the y coordinate, okay? Cosine is asking for the x direction. So that's why, hopefully, so far our understanding coordinates on the circle can be found doing cosine of x and sine of x. Now that's with a unit circle. Eventually you'll get into even this class and then future classes where there's a radius that's a little bit different. But really then you just multiply by r, the radius, to see how much bigger it is. But the The ratios of the 30, 60, 90 stay the same, whether it's a small triangle or a big triangle. So I'm going to walk through if I have sine of 3 pi over 4. So what I would do personally, like, you can have your unit circle around, but I would draw it. The more you draw it and get used to finding where these are, the better. So I'm thinking 3 pi over 4, well, that's really close to 4 pi over 4. I usually try to look for multiples of whole pies. So 4 pi over 4 would be here, and then I just go 1 pi over 4, which I know is 45 degrees before that, to get 3 pi over 4. Well, if I look at my drawing over here, there it is, okay? So what we're asking for then is, what is the y direction of that coordinate? So if I draw, we're going to go with a line just to keep this picture together and separated. If I draw a line from there straight down, oh, why did it go to that? Make it straight and then move it. This is really the answer to that question, is whatever this height is right now. Well, that's where we have to have a nice, clean understanding of our special right triangles within a unit circle. This radius is 1, both of these sides. I'm going to draw this one, I don't really need it, but this would be square root 2 over 2, technically negative because I'm going to the left, and then this side would be square root 2 over 2. Okay, so we got to know those special right triangles. If it was asked for the cosine, the answer would be negative square root 2 over 2, but this answer is square root 2 over 2. That is the y direction, and you have to get it exact. If you put this in your calculator, the sine of 3 pi over 4, and you were in radian mode, you'd get 0.707. So if you're seeing 0.707s, if you're seeing 0.866s, we don't want that decimal answer. We want the actual exact answer using our special right triangles. All right, so let's try the second one here. Get rid of this just because we want that answer shown. We'll do the cosine one in green here. So we're looking at for 7 pi over 6, and that's where we saw there was a little bit of a mistake, but we'll fix that. Again, just going through my thinking, 7 pi over 6 is a pi over 6 past 6 pi over 6. I'm always looking for those whole multiples of pi. So 7 pi over 6 is another 30 degrees past that. So here's my 7 pi over 6. And then it's asking me for the cosine of that. Well, the cosine is the x direction. So really every time you should just make the right triangle that goes to the x-axis. That's the best rule of thumb. Just make your right triangle. It goes from here. It's pretty far over. It doesn't get all the way to -1, but it's pretty far over there, and then just straight down. So there's my right triangle that I'm dealing with in this one. So the ratios in that 30, 60, 90. If I make this a little bigger on the outside, here's my 30. And there's my 60, and there's my 90 with the x-axis. So you can draw a lot of right triangles, which is funny that we feel like we're dealing with circles, but we're always going to be dealing with triangles. That if this radius is 1, we have to know the ratios of that 30, 60, 90. That remember the short side is always half of what the hypotenuse is. So across from the 30, the shortest side is 1/2. Across from the 60 is always square root 3 over 2. We gotta lock those in. You gotta have those memorized or understood, or else this isn't gonna go so high. So in the cosine, if I translate this back, which direction I go is really, really important. So I went in the negative x direction and the negative y direction. So I know the coordinate is negative square root 3 over 2, comma, negative 1/2. So the cosine is just the x direction, would be negative square root 3 over 2. So if I take away this triangle now, that green line is my answer. It's negative square root 3 over 2. Lastly, I wanted to introduce negative angles. Just like we always start at 1, 0, we still will. If it's a positive radian measure, we go counterclockwise. And now if we're going negative, we're going clockwise. So it's quote unquote not showing up on this picture, but I know a negative pi over 3, I'm going to go clockwise pi over 3. So pi over 3 is a 60 degrees. So actually, it lands on the same spot as 5 pi over 3. So this is the same location as negative pi over 3. So again, it's asking me for cosine. We'll make this one blue. So we'll go blue, x direction to about there, I'd say. And that gives me a hint, if it's all the way over to 1, these decimals should make sense, especially if you're using your calculator. If it's not on an exact, I can take the sine of 13 degrees, and it's just the y direction of 13 degrees on the picture. So if I complete my, but that's okay. Because I know this is the 60, I know that's the 30. That means I know this is a half. This is in my direction, negative square root 3 over 2. So my final answer would be 1/2. I can put that negative square root 3 over 2. It's helpful if I'm finding full coordinates, but if they just want the cosine, I just want the x direction. So that's kind of a recap of the last 2 days. Like I said, I put a blank unit circle on there that has spots for the radians, the degrees, and the coordinates. I didn't post any of this, but there's kind of like memorization tools if you want to look for like using your left hand. You can put so many fingers down to find like square root 2 over 2, and there's patterns, and Mrs. Stewart went through that if you have to find the coordinates, we want to use and understand those special triangles, but there are patterns and ways to start filling this in, and the more comfortable we are with the unit circle, the better. Just a look ahead, what we're going to start doing is we're going to start looking at sine and cosine as a function, meaning I'm going to plug in all of the, every single degree measure, and then I'm going to make a graph of what the sines are. What are all the y directions? So for example, the sine of 0 is 0 because I didn't go anywhere up or down. If I go to pi over 6, we're going to use the x-axis as our degree measures of pi over 6, well then I went up to 1/2. And I'd put a dot. And then I know square root 2 over 2, and then square root 3 over 2, and then 1. And then I'm at pi over 2. And then I can come back down, and eventually I'll have all these dots. And if you haven't seen sine or cosine curves before, eventually what we're going to get is just graphing all of those, all the y values, and this will go through in the next couple of days. Like this would be one rotation. I go up on the unit circle, I come back down to that middle of the unit circle, I go down to the bottom of it, and then I'm back to where I started at 2 pi. So that's upcoming, but I just wanted to link it to the unit circle that we are getting better with. All right, hope this helps.